Welcome. This PowerPoint is an introduction to Geographic Information Systems, otherwise known as GIS. GIS is a computer-based system used to capture, store, edit, analyze, display, and plot geographically referenced data. With the development of computers, cartographers were inspired to see exactly what these new machines might do for mapping. Dr. Roger Tomlinson was the head of an Ottawa group of consultant cartographers. He's been called the father of GIS, as it was his idea that promoted the use of computers for mapping. By 1969, Laura and Jack Dangerman founded the Environmental System Research Institute, known as ESRI, which pioneered the powerful idea of linking spatial representation of features with attributes in a table. This is the core idea that revolutionized the industry and launched the development of ArcInfo, a program that has captured about 90% of today's GIS market in North America. Intergraph has captured the market in Europe. Esri's products have evolved over time. In the beginning, ArcInfo was designed to produce coverages. This is a data model that stores vector data with both spatial information for the location and attribute information, which is descriptive data for each geographic feature. In the 1990s, developments such as faster and cheaper computers, network processing, electronic data publishing, and new data capture techniques such as GPS spurred rapid growth at Esri. Esri's first desktop solution, known as ArcView, opened up the possibilities of GIS to a whole new group of users. In ArcView, shapefiles were developed, which are spatial data files developed for geospatial data sets, which made it easier for the user to analyze. During the late 1990s, Esri re-engineered ArcInfo to develop a modular and scalable GIS platform that would work both on the desktop and across the enterprise. The result was ArcGIS, where geodatabases became the main focal point. ArcGIS came out with version 8. Geodatabases were developed to employ database technology for storage and to implement rules for relating spatial features which were connected or adjacent to each other. This idea is known as the rules for topology. The older version of ArcInfo included a basic set of programs called Arc, ArcEdit, and ArcPlot, which utilized the coverage data model and was built in a database program called Info that appears primitive today. All of those programs were command-based, meaning that the user typed commands into a window to make the program work. ArcView was designed primarily to view and analyze spatial data rather than create it. ArcView also used a simpler data model called the shapefile, although it could read coverages and convert them to shapefiles. ArcView was the first introduction to the Arc desktop, which in 2001 ArcGIS was released, and this was a synthesis of the powerful ArcInfo system with the easy-to-use interface of ArcView. This new desktop included Arc Catalog, which is a tool for viewing and managing spatial data files. It resembles Microsoft Windows Explorer, but it is specifically designed to work with GIS data. ArcMap provides the means to display, analyze, and edit spatial data and data tables. The Arc Toolbox provides a set of functions and commands for processing spatial data. In summary, the basics of the ArcGIS software include the ArcMap, which is used for mapping all spatial features, Arc Catalog, which is your library, and is used for managing, editing, and manipulating spatial data, and then your Arc Toolbox, which contains the toolboxes and tool sets for editing and processing spatial data. The two most common data models used in GIS are the vector model and the raster model. The vector model uses features where they are represented by one or more pairs of XY coordinate values forming points, lines, or polygons. The raster model is a data model that uses rasters or numeric arrays to represent real-world features. The vector model uses points or lines that are referenced by an XY coordinate, lines that represent linear features in the world, and polygons which represent areas bounded by lines with a centroid point. In this diagram, you can see points, lines, and polygons representing features, and you can also see annotated features right where Luxley Gardens, Broadmont, and the sewage disposal ponds are identified. Points, lines, and polygons represent features and are represented as feature classes when there is a collection of similar objects, such as a number of cities, which would be points, a class of rivers, which would be lines, or some lots of land, which would be represented by polygons. In an attribute table, features are identified as feature IDs, and objects are identified as object IDs. In ArcGIS, when features in an attribute table are highlighted, they are also highlighted in the map. In the raster model, raster data is represented by small cells as a series of rows and columns where each pixel has a value. The X and Y dimensions of each pixel define the resolution, and high resolutions represent raster data more precisely. Discrete rasters store features but in a raster format. They have relatively few values that change abruptly from one category to another and are therefore termed continuous. A digital elevation model stores elevation values. It has cells or pixels, each of which contain a single elevation, which are regularly spaced, commonly called continuous rasters because values range smoothly into one another, forming a continuous surface. Another type of raster is an image raster. They store brightness values and are commonly used to store aerial photographs or satellite images. Images contain bands to represent each pixel in red, green, or blue, also known as RGB. Another type of raster is the digital raster graphic, or DRG. A paper map, such as the USGS topographic map, can be scanned and stored as a raster. Here, each cell stores an index code representing a different color. For example, brown equals the value 5, and white would equal the value 1. There are many uses for GIS. Here is an example where it's being used for fire management and tracking and control. The orange or red circles are point data representing fire stations or fire lookouts, and those lookout points look out over the polygons identified by the pink lines when there is a fire outbreak. GIS is commonly used in epidemiology, where it is used to map disease and the geospatial and temporal distribution of certain diseases. This slide shows the outbreak of West Nile virus. Initiated in 1999 in Queens, New York, it then spread in 2003, where the highest population density cluster is in the central portion of the United States. Density distribution, as shown in the 2003 and 2007 maps, is shown by dot density clusters, whereas the 2010 map shows incidence of occurrence of West Nile virus using a graduated colors map. Police departments can track crime by mapping robbery, aggravated assault, and burglary as shown in this map, using different symbology to represent each of the different crimes. By doing this, they can actually identify neighborhoods where certain crimes are occurring more frequently than in other areas, knowing where to send policemen for patrolling. GIS can be used for managing emergency resources. On September 11th, the Esri teams were sent into New York City. Here they were asked to map several different debris fields, building damage levels, and environmental pollutants that were being carried by the winds to best decide where people should be evacuated and whether people should be let back into communities, to identify where buildings were at risk and compromised, and where best it would be to disperse response units. GIS is very useful in transportation planning and roadway expansion. This is called a transportation network. GIS is also very useful for utility networks and sewer system modeling for population growth or decline. In order to be successful in geospatial modeling, you must understand some of the basics about the shape of the Earth and its reference points. The simplest model of the Earth is a sphere, but the Earth is not a perfect sphere. It's a spheroid, also known as an ellipsoid. An ellipsoid is an ellipse which rotates about its minor axis. And if we really want to look at the true shape of the Earth, we must include its three-dimensional aspect. So a geoid is an even closer approximation of the Earth because it considers its irregular surfaces. All maps must be tied to a geographic coordinate system. A geographic coordinate system is a location reference system for spatial features located on the Earth's surface given by an XY coordinate. We use latitude and longitude, which are both defined by XY coordinates of a point. Latitude are lines or parallels that are angular measurements both north and south of the equatorial plane. Longitude are semicircles which measure the angles east and west from the prime meridian. This diagram shows the prime meridian and the equatorial plane as the reference points.